Okay, so trapezoids. Yeah. Who can remember? What?
Tuesday. I hope British people say Tuesday.
Oh, Tuesday. I thought you were talking about maybe like Tuesday, like February 2nd, 2022. Tuesday. I'm so excited. Hey, how do we find the area of a trapezoid? 1/2. I'm going to say we're going to add the two together. But yes. Okay. We take 1/2 times the height times the sum of the two bases. Okay. So what we are going to do, instead of drawing rectangles inside, we are going to draw trapezoids inside. Okay. So hopefully will fit just a little bit better. Okay, glad I can help. So this is what we're going to do. It's going to be very similar. N is the number of trapezoids, but our delta x, since we're talking about trapezoids, our delta x is now going to become the height of our trapezoid. Because what's going to happen is our trapezoids are going to look like this. And so delta x, that's going to be the height of our trapezoid because our parallel sides are what we consider our bases. We're just used to seeing trapezoids sitting rotated at 90 degrees. So if you need to look at it like this, okay, that might look like a more familiar trapezoid. Okay. Okay, the bases, base 1 and base 2 are our function values. Okay. Yesterday they were the height of our rectangles. Now they're the function, now they're the bases. Okay. And then like yesterday, we'll add up all of our area. Okay. Now I'm hoping we can find some patterns so that we don't have to find area plus area plus area plus area every time. But that's how we're going to start out, just like we did yesterday. I think the sun's finally going to. Oh, I'm so happy to hear. I was worried about
The email.
I did, but it was like.
Yeah, it was a long search.
Okay. Whew, all right. You're in a surgery.
Yeah.
Ooh, what kind of surgery? Okay. Okay. We took off messages. You think you can cover? Okay, let's check. Oh, yeah. Let's do that. Yeah, let's do that. Okay. All right, so go ahead and go to your pink foldable, and we are going to. We're going to draw our rectangles. I mean, trapezoids. So each like function height is going to give us our trapezoid. You see what I mean by that? Kylie's got it. Well, the first one, yes, looks like a triangle. What do you think? Do you think this will be a little bit more accurate? Seems that way, right?
Find the area.
Okay, so this is like the fourth time we've used this example, right? We know that delta x is b minus a over n, and so our delta x is 1/2. We use that to draw our trapezoids, okay? So I know that the first one's a triangle, but let's just pretend it's a trapezoid, and the height, I mean, it just has 0 height on the left, okay? So if we find the area of this first trapezoid, we have 1/2 times, remember the height of the trapezoid is delta x, and then our bases are our function height. So f of 0 plus f of 1/2. Okay. Our second trapezoid, we are going to be annoying, and then we'll make it look less complicated. Our second trapezoid, well, we have 1/2 times its height, which is delta x, times the two bases. So the left base is the function height at 1/2, the right base is the function height at 1. I hope you can pick up on some patterns as we go through this. Our third trapezoid, 1/2 times its height times the left base plus the right base. Oh, I'm going to run out of room. Okay. And then our last trapezoid, 1/2 times its height times the sum of the two bases. Oh my goodness. If we have to write that every time, that's annoying, right? So let's look for some patterns. Okay. Well, what do you notice? Every single trapezoid area has 1/2 times 1/2, right? And I'm going to keep it as 1/2. That's always going to be 1/2. And then the second 1/2, that is delta x. Okay. So we have 1/2 times delta x. Now, when we factor that all out, we have f of 0 plus f of 1/2 plus f of 1/2 plus f of 1 plus f of 1 plus f of, oh. So we have f of 0. How many f of 1/2 do we have? How many f of 1s do we have? How many f of 3/2 do we have? But then we only have one f of 2. We only have one f of 0. Okay, let's talk about why that's happening. All of our inner bases are shared by two trapezoids. I'm going to zoom in right here. Okay, two trapezoids share this base. Two trapezoids share this base. And two trapezoids share this base. But our end bases are loners. They're only for that one trapezoid. Okay, so we are going to double all of the inner bases. Okay, so we have 1/4 times 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4. I'll just tell you, it's 11/4. Yeah, go ahead. Okay. So as long as our delta x is the same, it's consistent, like it has been, then we can take a shortcut and write 1/2 times delta x and then add up all of the bases together. Now, how many trapezoids do we have? We have 4 trapezoids. How many numbers are we adding up inside? 5. We're gonna have 5 bases for our 4 trapezoids because we have 2 bases for each and they share the inner one. Okay. All right. So I told you the real area. How many of those do you have? Oh, I thought that was a third. Let me just take these over here. So our real area was 8/3. Of the 4, which one is the closest to 8/3? Trapezoid's closest. Okay, interesting. What? 8/3.
I would say the middle one.
It's very close between that one and this one.
This one wasn't exactly.
Midpoint was.
Oh,
And then there's is 2.6.
Okay,
And then the trapezoid is 2.75.
okay, so the midpoint was pretty close.
Yeah.
Like a little closer than trapezoid. Sometimes it's gonna depend on the curve, okay? But the trapezoid definitely we're fitting a little bit tighter to the curve. We're not quite like hanging over or under quite as much. Okay. So let's go ahead and like write down with how I want you to find the area. Okay. So if we have a curve from A to B, okay, then we're gonna find the area by taking 1/2 times delta x times f of A plus 2 times f of whatever's next plus 2 times f of whatever's next all the way until only 1 f of B. Okay, so we only have 1 of our first and last base and 2 of everything else in between. Okay, and how far apart are those bases going to be? Delta x apart. I mean, we're doing calculus, but we're doing geometry, right? We're finding area. It's been a nice break. F of B. This says F of B. What, you can't read that? It's a little bit. Yep.
Change your font size, or do you have to like zoom in and zoom out?
I could like make this tiny type smaller, I guess, like that. But I like it a little thicker, I guess, so that way it's easier to see for you. Okay. All right, so we're gonna do this example. So write down what you need to. We're gonna work through it together with our calculators, of course. All right, so we have x squared plus 1. We have 6 trapezoids from 1 to 2. So if we are going to calculate delta x, we are going to take b minus a over n. Yes. 1/6 is delta x. Fine. our area is 1/2 times delta x times, now we need to add up all of our bases. So we have 1 base of length f of 1. We have 2 delta x later, 2 delta x later, 2 delta x later. Oh, shoot. Two delta x later, 2 delta x later, but only 1 at the very end, f of 2. I know that 10/6 and 9/6 and 8/6 can all be reduced, but I don't really care that much right now. It's 7. Why are there 7? Yeah, because there's 6 trapezoids and we have like the front end and the back end of all trapezoids. So there's always going to be one more number in there than there are trapezoids. Okay, so now you get to put this into y equals and plug in travel away. Give me this number. Are you okay with letter 7? Yeah. You don't love it. Okay. Question mark?
Yes.
Okay, he is very unsure about his 3.3.
It's a lot of this. I definitely agree with you.
It's more than just 3.3.
3.3.
Or 721 over 216 to be exact. Okay, with an approximation of 3 decimal places or a fraction. You do you. But let's just make sure you can get there.
Oh, I just hit clear.
Right?
It's annoying doing it in the country.
Especially when you have a TI-83, huh? The TI-83 doesn't have the shortcut to the Y one. They have to go through a menu to get it, right, Paul? He doesn't know. Does anybody need help with their calculator? Oh. What are you doing? So you need to do 2 y2 y1. Very good. Yep. Okay, we are going to finish out today. I would like you to draw down this chart. Or like, I need you to write out this chart. We don't always have an equation. Sometimes we collect data and we have a table of values. right? Science people. Yeah. Sometimes we collect data in consistent intervals and we have a table of values. So what if I give you a table of values and I ask you to find the area under the curve? How are you going to do it? We're going to use our approximations. But I want you to have this written down first. And that we're going to do n is 3. Yeah. Huh? Oh, that's too much work. Too much work, Kylie. We don't need to do that.
Graph.
Cool. So if n is 3, then delta x is b minus a over n. What's delta x? 1. So we are going to have a rectangle or trapezoid from 0 to 1, 1 to 2, and 2 to 3. Yeah, let's do that. Okay. So if I'm going to do a left-hand approximation, I have delta x times the sum of our heights. Look at our table. What is the height of the left-hand side? 2, because this rectangle goes from 0 to 1. The height on the left is 2. What's the height on the left of this second rectangle? 6. And how about the third rectangle? 4. Whoa. I just went to the left function value of each of those little subintervals. What about the right? Delta x is 1. And if we look at the function heights for our right-hand endpoints, from 0 to 1, 6 is on the right. From 1 to 2, 4 is on the right. And from 2 to 3, 5. This is so great. We don't really have to think that hard, do we? Okay, I thought you'd be a little more excited. It's cool. It's Friday. All right, how about midpoint? This is great because we have middle numbers for each of them. What's in the middle of the first one? How about the second rectangle? And the third? Oh, yeah. Good job. Thank you. Thank you. Okay, a little bit more excitement. Now, this is the last thing, the trapezoid. We always have the 1/2 times delta x is our height times we have our very first base plus 2 of our next base plus 2 of our next base plus 1 of our last base. See? Did you do that right? Oh, I definitely multiplied something that should have been added. It's a Friday. Okay, so here we go. You have a worksheet. Front of the worksheet, trapezoids. Back of the worksheet, tabular data. Table, tabular data.
Right, Isaac? I think he needs to get these switches.
Okay, number 6 is gonna make you think. Let it make you think. Let it make you think.